How can I help you today?
I want us we go through what is on the board.
The board shows a simple neural network with two inputs, x1, x2, a hidden layer with two nodes, and one output. The middle section provides the equations for the hidden layer's pre-activation values. These calculate the weighted sum of the inputs plus the biases B1 and B2. The bottom line shows a matrix expression that attempts to represent this calculation by multiplying the input vector, x1, x2, by the weight matrix. However, it omits the biases B1 and B2 that are included in the detailed equations.
So we should add them. Where should we add them?
You should add the biases as a vector to the result of the matrix multiplication. The corrected matrix expression should be x1, x2 times the weight matrix plus b1 plus b2.
Okay, so let me rub here. So I add them here. Bias 1, bias 2. This one is addition. So that we get our ZH1 and ZH2.
That's exactly right. The corrected matrix expression now accurately represents the full pre-activation equations for the hidden layer.
Okay, now what next from here?
The next step would be to apply an activation function, such as ReLU or sigmoid, to the pre-activation values ZH1 and ZH2. This determines the actual activated outputs of the hidden layer.
Okay, which one is the best? Is it ReLU or sigmoid?
Neither is necessarily best, it depends on the task. ReLU is generally preferred for hidden layers because it performs better in many cases, while sigmoid is often used for the output layer, especially in binary classification problems.
Okay, I think which one is this one that I picked?
That is the sigmoid function,
Yeah, that's
denoted
the
by
sigmoid.
sigma of.
Yeah, it is the sigmoid function, and I hope it's correct. Let's see how whether the math is correct to get the final output y hat.
The math is correct. The equations define the sigmoid function, calculate the activated outputs of the hidden layer using sigmoid, then compute the final output by applying sigmoid to the output pre-activation.